Alright, here we are, Lesson 12, Unique Triangles, which include two sides and a non-included angle. So the materials you'll need for this lesson is a compass, a protractor, ruler, and blank paper. So for the exploratory challenge, predict, record, and justify whether you think the provided criteria will determine a unique triangle for each set of criteria. You're going to use your tools to draw a triangle ABC in the space below, provided A and B is 5 centimeters, BC is 3 centimeters, and angle A is 30 degrees. Continue with the rest of the problem as you work on your drawing. So here is the first part of the drawing, and what is the relationship between the given parts of triangle A, B, and C? Well, you have two sides, the 5 centimeters and the 3 centimeters, and a non-included angle, which is provided. So which parts of the triangle can be drawn without difficulty? What makes this drawing challenging? Well, the parts that are adjacent, the line segment AB and angle A, are the easiest to draw, but it is difficult to position the line segment BC. So for part C, a ruler and a compass are instrumental in determining where C is located. So even though the length of segment AC is unknown, extend the ray AC in anticipation of the intersection with segment BC. We're going to draw segment BC with a length of 3 centimeters away from the drawing of the triangle. You're going to adjust your compass to the length of BC, and you're going to draw a circle with center B and a radius equal to BC, or 3 centimeters. So let's go ahead and demonstrate this. So here we are with our paper. We'll go ahead and zoom out a little bit. And I'll go ahead and start from the very beginning, where we need to draw a line segment and also a segment that is 5 centimeters. So let's go ahead and draw our first segment. We know that this is going to be angle A. Oops. We know that this is going to be angle A, and it is 5 centimeters. So what we need to do is we need to create an angle A, which is 30 degrees. Let's see, how about we turn this over the right direction and measure 30 degrees. So once we've measured 30 degrees, now we can go ahead and mark our angle. So here we have our 30-degree angle. We also need to mark that this angle, or this line segment for part B, is going to be 5 centimeters. So here is, let's go ahead and mark 5 centimeters, which is right here. So this point right here is going to be point B, and this line segment is 5 centimeters. So now, how do I know where 3 centimeters is going to be? Well, I need to use my compass like what was explained, and we need to measure 3 centimeters using our compass. So if I put the 0 with the point and 3 centimeters, open this up to where we have 3 centimeters. Now I'm going to use this to draw a circle. The circle is going to be, or the point of my circle is going to be where point B is. So here is point B. And what I'm going to do is draw the circle all the way around. Alright, so notice what happens with this. Actually, I'm going to need to make this a little bit longer. There we go. Notice what happens with our circle. If our circle is 3 centimeters for the radius, then what happens is it crosses our line segment in 2 places, here and here. Remember, if this is 3 centimeters, then this line connecting here is 3 centimeters. And also, where it is intersecting here is also 3 centimeters. And we can double check that by measuring. I'll have to measure it from 10, but between 10 and 13 is 3 centimeters, and between 10 and 13 is 3 centimeters. So what ends up happening is I can have 2 different triangles. These are not unique. So here's 3 centimeters. This is also 3 centimeters. So AB is 5 centimeters, and we could call maybe this C1 and C2, because both of these are 3 centimeters. Remember, the information we were given was that we have 2 adjacent angles, so that's AB and BC, and a non-included angle. So that means that these 2 sides right here could actually be either coming in or going out, because the circle crosses our line segment in 2 different places. So that's exactly what we have here. We have 5 centimeters with a circle with a radius of 3 centimeters, and it crosses in 2 places. So how many intersections does the circle make with segment A? What does each intersection signify? Well, we have 2 intersections, and each intersection represents a possible location for the vertex C. So now we complete the drawing of triangle ABC, which we just did, and we end up with what we had on our paper, and they call it C1 and C2. So did the results of your drawing differ from your prediction? Number 2, now attempt to draw triangle DEF in the space below, provided that DE is 5 centimeters and EF is 5 centimeters. And we have an angle F of 90 degrees. Continue with the rest of the problem as you work on your drawing. So how are these conditions different from those in exercise 1? And do you think the criteria will determine a unique triangle? Well, the provided angle was an acute angle in exercise 1. Now the provided angle is a right angle. Your possible prediction could be that since the same general criteria, 2 sides and a non-included angle, determine more than one triangle in exercise 1, the same thing could possibly happen in this situation. So here you should have 3 centimeters for EF, and we have the angle F, which is 90 degrees. So what is the relationship between the given parts of triangle DEF? Well, we have 2 sides and a non-included angle are provided. So describe how you will determine the position of line segment DE. Well, I will draw a segment equal to the length of DE, or 5 centimeters. You can adjust your compass to this length and then draw a circle with center E and a radius equal to DE. This circle should intersect with ray FE. So when you do this, this is what you get. So how many intersections does this circle make with FE? Well, it only has 1 intersection. So now complete the drawing of triangle DEF. How is the outcome of DEF different from that of triangle ABC? And this is your triangle that you should have. Well, in drawing a triangle ABC, there are two possible locations for vertex C, but in drawing triangle DEF, there is only one location for vertex D. Did your results differ from your prediction? All right, number 3. Now attempt to draw triangle JKL. You are provided with line segment KL is 8 centimeters, KJ is 4 centimeters, and angle J is 120 degrees. Use what you drew in exercises 1 and 2 to complete the full drawing. So you should have something that looks like this. You have a line segment J going off, then you have 120 degrees, and JK is 4 centimeters. So again, you should only have one place where the circle will intersect the ray JL. So review the conditions provided for each of the 3 triangles in Exploratory Challenge and discuss the uniqueness of the resulting drawing in each case. Well, all 3 triangles are under the condition of 2 sides and a non-included angle. The non-included angle in ABC is an acute angle, while the non-included angle in DEF is 90 degrees and the non-included angle in JKL is obtuse. The triangles drawn in the latter 2 cases are unique because there's only one possible triangle that could be drawn for each. However, the triangle drawn in the first case is not unique because there were 2 possible triangles that could be drawn. So which of these 3 cases or subconditions of 2 sides and a non-included angle determines a unique triangle? Well, unique triangles are determined when the non-included angle in this condition is 90 degrees or greater. How should we describe the case of 2 sides and a non-included angle that does not determine a unique triangle? The only case of 2 sides and a non-included angle condition that does not determine a unique triangle is when the non-included angle is an acute angle or less than 90 degrees. So notice how the radius in the figure in exercise 1 part E can be pictured to be swinging between C1 and C2. Remember that the location of C is initially unknown and that the ray AC is extended to emphasize this. All right, let's wrap it up. A triangle drawn under the condition of 2 sides and a non-included angle, where the angle is acute, does not determine a unique triangle. This condition determines 2 non-identical triangles. Consider the triangle correspondence. Triangle ABC is the same as triangle XYZ. That corresponds to 2 pairs of equal sides and 1 pair of equal non-included angles. If the triangles are not identical, then triangle ABC can be made to be identical to triangle XYZ by swinging the appropriate side along the path of a circle with a radius length of that side. A triangle drawn under the condition of 2 sides and a non-included angle, where the angle is 90 degrees or greater, does determine a unique triangle. All right, we'll see you in class.